Hi, I'm Manoj. I've spent over a decade building software monitoring products. I know monitoring has a problem. Troubleshooting is just too hard. We rely on dashboards, ad-hoc exploration, and alerts. Dashboards are a good start, but they're often incomplete. Ad-hoc queries are flexible, but writing queries is slow and too often requires an expert who knows what to look for. While we need alerts, many teams struggle with alert fatigue. We need a new kind of tool built to help teams to spot problems, solve them quickly, and remove the toil from monitoring. So we built Asserts. Asserts is a metric intelligence platform. By analyzing your existing apps and infrastructure metrics, Asserts discovers the entities such as pods, nodes, services, their properties, and relationships between these entities to build a knowledge graph. The discovery process constantly updates the graph while at the same time keeps a history to enable time traveling. For each entity, Asserts runs automated health checks to discover changes and problems. We call these checks assertions, and they remove much of the manual effort that goes into troubleshooting. Now let me show you how we used Asserts to troubleshoot an outage in our production cluster. To monitor our production, we have defined service level objectives on latency and availability for all our key services. On the evening of November 17th, Asserts notified us that the APS server latency SLO violated and the pods in our query service VM select were crash looping. By clicking on the View Impact link on the alert, we could view all the incidents at the time of outage. Here, we could see the APS server latency spike coinciding with the query service health degradation. A quick look at our SLO dashboard confirmed the sharp drop in our error budget. We wanted to view the health of our platform. The View button on the SLO chart launched the Assertion workbench. Here in Workbench, we are looking at assertions firing on the services at the time of outage. We categorize the assertions by these 5 categories: saturation, amend, meaning change, anomaly, failure, and error. In short, safe. The services are ranked by number of assertions firing on them. VM Select is having the most problems, so it has risen to the top. By hovering on the thumbnail sketch, we confirmed at the time of VM Select crash, Grafana is experiencing resource anomaly assertions. VM Alert and the ingress controller have recorded errors, and APS server has exceeded the latency P99 threshold. We wanted to understand if and how these services are connected to each other, so we toggled to the entity screen. Here in the entity screen, Asserts shows a visual map of our service architecture and its health. Notice the red ring around VM Select. This means that an assertion is telling us that the service is unhealthy. Asserts also records which services depend on VM Select. So you can see that the VM Alert services depend upon VM Select. And VM alerts are unhealthy too. Now we know the impact of the problem. The crash in VM Select is causing errors in VM alerts as well. We also noticed the Grafana service depends on VM Select to execute queries, and the requests to Grafana are coming from APS server and Nginx ingress controller, our external load balancer. We now wanted to look into the cause of crash for the VM Select service, so we dived into the assertions firing on it. We noticed right around the time the failure assertions were recorded, there were memory saturation assertions. Saturation assertions are continuously checking your infrastructure metrics to make sure your app has the resources it needs to stay healthy. When a resource is running low, Asserts records a resource saturation assertion to point at the problem. By expanding the saturation chart, we asserted the memory usage was over 95% for the pod right before it crashed. We launched the contextual and automatically generated dashboard for the pod. Here, Asserts shows the golden signals, which is request rate, latency, and error rate, the resource metrics like CPU, memory, and network, and runtime metrics depending on the service runtime. VM Select is a Go service, so we are seeing Go metrics. We drilled into the memory metrics to see how much memory this pod was using and how close it was to running out of memory entirely. Back in Workbench, we expanded the assertion charts for Grafana and observed a 100x spike in network bytes at the time of VM Select crash. A quick look at the ingress controller assertions and error charts confirmed that the requests to Grafana are taking too long and erroring out. This was positive evidence that our users must have been evaluating particularly heavy queries via the Grafana query interface. The root of the problem became clear. A user fired a series of queries and executed it via Grafana, and that required too much memory to evaluate and caused a crash of the query service VM Select. This blocked the alert rule evaluation for some customers and violated the APS server SLO. Let's pause to consider how this troubleshooting experience would be different without asserts. The standard tools for troubleshooting with metrics are pre-built dashboards and ad-hoc exploration via query languages like PromQL. For the dashboard to get us to the root cause, we would have needed to anticipate every possible problem and then add all the relevant metrics. When an alert fires, a human has to linearly scan to decide which one is worthy of further investigation. This process gets laborious very quickly, so often to keep things manageable, dashboards contain only the most important metrics, and troubleshooting is done via slower ad hoc exploration. And then there is the cognitive load of stitching it all together. One will need to be an expert with the most current architecture of your app and infrastructure, and then build a mental model of the interconnections on the fly. Now let's compare this with the Asserts experience. You start by looking at the potential problems, which results in a much shorter list. Once we have constrained our exploration to the relevant signals, troubleshooting is much faster. And with a live architecture view and contextual dashboards at your fingertips, both space and time correlation is a breeze for everyone in the team. As we just demonstrated, we could pinpoint the problem in our platform down to the 8 affected services and just a handful of metrics in a matter of minutes by merely navigating from SLO to Workbench. Contrast this with an experience of linearly scanning thousands of metrics across 40 plus services and 100 plus pods. The other question we often get asked is, will Asserts work for my architecture? Asserts is natively built for and on Open Prometheus ecosystem. Asserts builds its live architecture view just with Prometheus metrics, and PromQL is the language for assertions and SLO definitions. So if you're already on or would like to move to the Open Prometheus ecosystem, we would love to connect with you. Thank you.